Alright, hello. So, today we're going to work on camera stuff. We're going to work our way through camera equations and then hopefully end with rendering. And then I don't have like details. I didn't prepare detailed plan of the lecture or of the talk. So, let's see how it goes. I sure hope I can finish it. But yeah, worst case I like re-record it or make some cuts if it's super boring. So, let's start. So we're going to assume that the viewer is a point, and it's like an eye point. So here's the eye, and already I'm starting to paint it in a not the prettiest way. Yeah, so here's the eye, it looks to the right, and then here's the point. So the eye is the point really, and there's like a coordinate system that begins here, and we're going to look to how it's defined in a second. And then in front of the eye, a distance of 1, there's like a plane, or like a piece of a plane, or piece of paper, you could think about it like canvas. And then in the distance there's like some object that the eye perceives. So a triangle that has 3 corners. And then we pretty much make a line that connects the center of the eye with the side of the triangle, and then another one, and then so maybe let's use colors or something. So this is blue point, and here's like a where the blue point is on the picture, and then here's the red point, and here's the red point of the triangle on the image, right? And then like yeah, we would pretty much have the yellow, and then yellow would be somewhere here, right? And then this picture makes it easy to see in which way we could figure out where the triangle is on the picture, right? So we could just take this line that connects the middle of the eye with the side of with the vertex of the triangle, and then project it to just basically, so we have equation for this line, and then we evaluate equation for this line at z equals 1, right? We project to this plane, and this is exactly where the side of the end of the vertex of the triangle should end up, right? And if you recall, previously we talked about this like coordinate systems and so on, right? So usually when we have the image, we begin counting pixels. So let's say this image is like 640 by 480. It's like a computer pixelized image. It begins, so we begin counting in this direction x, right? So 640 is first, and then y is the other direction, and that goes down. So that's how that's how, at least how I remember it, right? So and the coordinates, 3D coordinate system of the eye is going to follow this convention pretty much. So the eye has like down axis, and then it has like right axis, and then it has like a front axis that goes towards toward the picture, right? So, and this is again like so to the down it's y, to the right is x, and then towards the image is z. So that's how it works. And yeah, I would call it maybe camera frame, and this is distinct from, and so we're going to make a distinction between the image frame, which is here, and then camera frame, which is so image frame is measured in pixels, and camera frame is measured in meters, or like whatever, in some kind of unit. And this makes it a little bit different. And just to make it super clear what we're talking about, let's just draw this situation again from the bird's eye view. So here's the I, here's the Z coordinate, here's the X coordinate, Y coordinate goes away from us, so sort of to the ground, and then the I is point, and here's like the image plane. It's at z equals 1. It has some like arbitrary chosen parameter width, so height and width, and here's some kind of object that we perceive, and then we this object maybe has like some vertex, right? We can call the vertex A, and A has some coordinates, maybe like X is, I don't know, like -2 or something. Then Y, let's just say Y is 0, why not? And then Z is I don't know, maybe 2.5 or something, or maybe 2, something like 2. So and this is all in camera frame, so in a reference frame that begins in the middle of the eye. And then if I want to figure out the coordinates of if I want to figure out the coordinates of this point, I pretty much just need to normalize to have z equals 1, right? So if I do like x over z, that's -1, then y over z is just 0, and then z is 1. And then I could draw this, so if I have my picture image again, and then here's my x and y, then I would have like here's maybe -1, right? So, and then y is 0, so it's somewhere around here, right? So like over here. So it kind of makes sense, right? Yeah, and then this shows us how we could actually render things. So we could assume a scene and then render or predict what the robot should see. So by first transferring so let's say like we have an object, right? So there's some kind of object in the world, and then it's in word frame. Then we could all we need to do is we need to have object, so this is what we have, and then we want to figure out what would be the coordinates of the object in the camera frame. So in order to do this, we would need like a inverse of the position of the camera in the word frame, and then we would need to let me just move it a little bit. Yeah, I want to move this away, and then I want to move this to the left. Right, so now we're ready. So this is like inverse, so this is inverse of camera in the world, position of the camera in the world, maybe with this like coordinate flip, right? So don't worry about the details, we're going to come back to this later, but like you have to notice that like how the word frame, it goes like this, and then camera frame y goes down. So coming back to this, like we could figure out the position of the object in the camera frame by composing the position of the word in the camera frame and then a position of the object in the word frame, right? So they cancel out sort of, as we have talked in the past. And then we have this in camera frame, and then we normalize the z, and then in this way we know exactly where the object is. So yeah, that's pretty cool. That's like the gist of it, and yeah, we're going to practice this in a second. So let me see. So yeah, let's zoom into one more detail, right? So when we have so let's say we did this conversion, right? And like we have an object in the camera frame, then how do we go to pixels? How do we go to the image frame? So the way it works usually is as follows. So we have, here's the camera frame. This is like 0, 0 in x, y. This is x, this is y. 0, 0, and then there's like a z equals 1. And then so the image goes maybe from like, I don't know, minus 1.5 to 1.5, something like this, and then from minus 0.7, or maybe like, I don't know, maybe minus 1 to 1, something like this, more or less. And then we want this to map to a world in which this is 0, 0, this is 640, 0, this is 480, 0, and so on, right? And then the word goes like this. So the way it's kind of easy to notice that this is linear transformation, and it's linear in each of the coordinates, so it's just like linear shift and scaling. So x in pixels is going to be something called f of x times x in normal terms plus c of x. So we can try to figure out. So we will want to map minus 1.5. We will want this to be 0, and then 0. So here's like minus 1.5, right? And then 0 we'll want to map to half, so that's 320. So from this we can figure out immediately that cx has to be 320, and then from the above equation we can see already, so f of x plus c of x, right? So f of x has to be 320 over 1.5. So we just have the equation pretty much. So xp equals like fxp plus cx, and then yp equals fy yp plus c of y. And this has like a fancy name in literature. It's like camera equation and whatnot. You can, I just, for the sake of your understanding, let me show you. So yeah, here's a pretty typical way to write it. Here's another one. So yeah, we'll notice this like 1 over z. That's how people write it. So xyz gets mapped through this camera matrix, and this fx and cx, those are often called camera intrinsics. Camera intrinsics. Let me write it down. Camera intrinsics. And then there's like calibration algorithms and whatnot that try to figure those out. And yeah, sometimes like aberration of the lens and so on is also captured in camera intrinsics. We're just not going to worry about it. And then camera intrinsics are different to extrinsics. So extrinsics is like where the camera is mounted, pretty much, like stuff that's like external to the camera. So yeah, honestly, from the theory that's like pretty much it. And then, as always, it's or like maybe as usual, it's mostly about practice. So it's mostly about really working your way through those equations and just like getting practice with those. And that's what we're going to do right now. Let me just Ooh, I lost my mouse. That's so sad. Let me restart the recording.